Right, here's the question then. Parts A and B. So I've got it summarized over the page here, so let's have a look at it then. So express this in this form while we just split the fraction up. So here, y is equal to, split the fraction up, 12 over x plus x squared root x, this over what's underneath, over x, which is equal to 12x to the minus 1, plus, this is x to the 2, one of those will cancel with the one underneath and have x root x, which is just x to the 3 over 2, isn't it? X times root x. So there's the form that we wanted. So I'm just going to flick back to the question to check we've done everything. Yep, that's fine, hence find dy dx. Okay, so let's find dy dx, so part B. So here, dy dx then is equal to, power rule, minus comes down, so it's minus 12, x to the 1 less, plus power rule, 3 over 2 comes down, x to the 1 less than 3 over 2, which is a half. So there's the dy dx then. Find the normal at x equals 4. So at x equals 4, dy dx equals then minus 12 over 4 squared is underneath, plus 3 over 2 times 4 to the half. That will be 4 squared is 16. 12 over 16 is 3/4, isn't it? So it's minus 3/4 plus, the 2's will cancel, because this is just root 4 is 2. So that's just plus 3. 3 take 3/4 is 2 1/4. Or 2.25 if we want to write it in decimal form. Okay, so that would be the gradient, so the normal. Find the, let's just flip back to the question once more. Find the equation of the normal at x equals 4. So, what have we got then? So, y minus, at x equals 4, we'll still need to get y, won't we? So y equals then at x equals 4. Put it in here. 12 over 4 is 3, isn't it? Plus x to the 3 over 2, that'd be 4 to the 3 over 2, which is equal to 3. 4 square rooted is 2, and 2 cubed is 8. So that's 11. So now we've got the coordinate and the gradient of the tangent, we can get the equation of the normal. Consequently, our equation of the normal is then y minus the y coordinate, which is 11, is equal to the gradient of the normal, where the gradient of the tangent is 2.25, or 9 over 4, so it would be minus 4/9, wouldn't it? And then it's x minus 4. It's minus 4/9 because this product must equal minus 1, mustn't it? Okay, that's what we've got then. So that's the equation. We could move the 9 up if we wanted and expand the bracket, but I'm okay with it being like that. I will move the 11 over, so it's minus 4x over 9, and then it's minus plus 16 over 9, plus 11. Okay, so I'm just going to tidy up a bit more. So 9y then is equal to minus 4x, and then it's 99 here when I've times by 9, plus 16 is 115. So finally then, move these two things over, 4x plus 9y minus 115 equals 0. That's easier on the eye in this form. Okay, so I'm going to scroll back up now. We found the normal. Stationary point P, show the x coordinate is 2 to the k and find k. Stationary point then, when does dy dx equal 0? So here's dy dx. minus 12x to the minus 2. So part 3, minus 12x to the minus 2. So I'm just going to copy it down from above. D by dx, that. Plus 3 over 2x to the half. Let it equal 0. Plus 3 over 2 x to the half. Let it equal 0. So this moves over there. So 3 over 2x to the half then is equal to, move the 12 over 12x to the minus 2, which we can write underneath. Let's do that then. So that'll be over x squared, wouldn't it? And move that up to be up to the top. So times you add, so that'll be x to the 5 over 2. And then the 2 12s are 24. That moves up to be with the 12. And the 3 moves down. And you get 8. Okay, so what have we got here then? Now we do power 2/5, don't we? So x, if we do power 2/5, this will be x to the 1. And power 2/5 on the other side will be 8 to the 2/5. 64, 1/5, fifth root of 64. 64, the 5th root. Which is equal to, oh that's good, because this is 2 to a power. 2 to a power, what is that? 2 to the 6. To the 1/5. So it's equal to 2 to the 6/5. We could have put 2 cubed in here, couldn't we? And done it that way, 2 to the 6/5. But we got there in the end. So the value of the power, find k. K is equal to 6 over 5, which equals 1.2.